All right, this is Populations and Resources Lesson 2.7, Activity 3, Part 2. You should have just annotated these evidence cards and then selected which card you think between A and B is the best piece of evidence, strongest, and then selected which card between C and D is the strongest by putting a star on them, and then also you would have numbered all four of these cards 1 to 4, where 1 is the strongest evidence card and 4 is the weakest evidence card. So now we're going to talk about that. If we look at evidence card A, we can see that this sample was collected at 6 different locations and spread out where zooplankton population is. This is the strongest piece of evidence. If we look at evidence card D, there is only the sample was only collected from sightings from the Glacier Research Center. So even though the leatherback sea turtle can be found throughout the entire sea, this is only looking at what they can see right here. So this would be the weakest evidence. This is the lowest amount of recordings it's collecting from one location, versus A is collecting from a spread out location. Now there's 6 here. You might say, well, evidence Cardi B is got 6 locations, but these are all only on the shore from what you can see. So you're really only getting the shore. It's not really spread out. It's still much better than B, or I'm sorry, C or D in the sense of the number, but definitely in terms of spreading out, A is the best. And then, C is somewhat spread out too, even though it's just kind of in the small area. It's not really, there's not a lot of numbers. So A is the strongest and D is the weakest, and then B and C are kind of like you can go back and forth between those two about which one's stronger or weaker. What's important is that we can clearly see that A is the most spread out with the largest number, and D is the least spread out with the smallest number. So that makes D the weakest and A the strongest. It's also important to point out what the conclusions are between the cards of the same type of population. So on evidence card A, the zooplankton is saying that it was stable and then started to increase in 2000. B was stable and started to increase around 2000. So those are saying the same thing, even though they're different samples being collected. Now, if we look at the leatherback sea turtles, C is saying that it was stable and then started to decrease. And D is saying that it was stable the whole time. So it's pretty clear that the zooplankton evidence does a better job of representing the whole population. So we would say overall the zooplankton evidence, cards A and B, is stronger, especially because they are showing the same trend. Now, evidence card C and D are showing different trends. We know they don't do a very good job of representing the whole population, but they're also showing different conclusions. One is saying that it decreases after 2000, and one is saying it just stayed stable the whole time. So what we need to think about is, which claim do we think is best supported by evidence? So is there a change to the zooplankton that's causing the births to increase? Or is there a change to the sea turtle population that's causing the deaths to decrease? So if we focus on claim 1, evidence card A, and I'm going to use this now, evidence card A supports claim 1, and it's saying that the zooplankton population increased. So if the zooplankton population increases, there is more energy storage molecules for the moon jellies to eat. And since there's more energy storage molecules, that means they're more likely to live longer and reproduce more. So that clearly supports claim 1. Again, you did this in your models in the previous activity. A larger resource population, and in this case the zooplankton is the resource population to the moon jellies. A larger resource population would provide more energy storage molecules, and then the moon jellies can use these energy storage molecules to reproduce more, which results in more bursts. So let's talk about claim 2. So real quick, card A and card B both support claim 1. If we look at claim 2, we were trying to see, does any of this evidence show that the sea turtle population caused deaths to decrease in the moon jelly population? So are there less sea turtles? So if we look at card C, it says that after 2000 the population started to decrease. So when you did your model, a smaller sea turtle population would require less energy storage molecules, so the sea turtles would eat fewer jellies, resulting in fewer jelly deaths. So evidence card C supports the sea turtle population going down, which causes deaths to decrease in the moon jellies, so then now we have fewer deaths. But evidence card D is the opposite, saying that it's, or not opposite, but it's different. It says that it's stable. So we can't really eliminate claim 2 because the evidence card C supports it. Evidence card D doesn't support it, but we do know that both evidence card C and D are not strong evidence. So we can't really say for sure that claim 2 should be eliminated. So sometimes ecologists don't have specific evidence about how a population has changed or what the population numbers are. So we can't be sure about whether the sea turtle population is stable, increasing, or decreasing because neither of the samples from C or D does a very good job of representing the whole population. So we'll need to get more evidence about this. Now you might think, well, it's not good evidence, so we should just get rid of that claim, but we can't say that because the evidence isn't really giving us any sort of conclusions. So you can go back and make changes to your annotations if you would like, or changes to the stars to show which cards are the best piece of evidence, or change the number. But make sure either way that you have turned in your evidence cards into Notability.